Hello students. So today we are back with our PYQ series and today's topic is cubes and dice. So this topic has made comebacks of sorts in 2023 CSE after a few years of gap. So again, let us cover PYQs of last 5 years based on this, primarily of 2023 because this has been a comeback of sorts. Let us see. This year, this was the question. A cuboid of dimension 7 into 5 into 3 is painted red, green and blue on each pair of opposite faces. Now for this, you need to know how the cuboid looks. So we have a cuboid. This is how a cuboid looks. Right, this is a cuboid. It has 6 faces, 3 pair of opposite faces. So they are saying that it is painted red, green and blue. So let us say this is red, this is red, this is green, this is green and this is blue and back on that side is blue. Right, fine. Faces of dimensions 7 into 5 into 5, 5 into 7, 7 into 3 respectively. Of course, okay, they have given where is the color as well. So anyway, that won't matter a lot if you look at the sentences. So basically, you can assume this as 5, this has 7, this has 5, and this has 3, and then they are saying 7 into 5 has red, yes. 5 into 3 has blue. 5 into 3 has blue. Okay, so this is blue according to them, and this is green. This is green. Now they are saying cuboid is cut and separated into cubes of 1 centimeter side. So cuboid is being cut into cubes. So here we have 7 cuts. Here we have, and so on. So each of these cuts will convert or cut this cuboid into smaller cubes of size 1 by 1 by 1. Right. So volume of each of these smaller cubes is 1 and volume of cuboid is 7 into 5 into 3. So 105. So there will be 105 such cubes that will be generated. Now let us see the questions. There are exactly 15 small cubes with no paint on any face. Now imagine for there should be no paint on any face of a cube. The cube cannot be on the surface. The cubes that are inside will all have no paint. But if the cube has even one surface on the surface of cuboid, then it will get painted. It's as simple as that. So what we do is, see, this is consider this is a 7 wala side. This side 7 centimeter side. So what we do, we come one inside so that this face is not exposed to this surface, and we have to come one from inside, one from this side inside, because otherwise this surface would be exposed to outer surface, and if the exposure to outer surface is there, that surface at least will get colored. So one from this, 2 inside. So this becomes 5 side. Similarly, from this is side 3, 1 inside. So this becomes 1, and 1 inside. This becomes 3. So this is a cuboid inside of this bigger cuboid, where we reduce each side by 2, 2, 2. And here we have all the cubes where there is absolutely no paint on the surface. How many are there? 5 into 3, 15 into 1. So 15 volume. Each smaller cube is of 1 volume. So 15 cubes would be there. So this statement number 1 is absolutely correct. Now let us see the statement number 2. There are exactly 6 small cubes with exactly 2 faces. One face painted with blue and another painted with green. Now we want 2 faces painted, one with blue, another with green. So these corner pieces are absolutely useless because corner pieces 3 faces will be painted. But we want only 2 faces to be painted. And we want them to be painted with blue and green. So this is blue, this is green. So this interaction, blue-green interaction, green, blue, this interaction, 1, 2, 3 and 4. These 4 are the intersections of blue and green. Here we have this line, here we have this line. These are 5. These are 5, right? 5 cubes. This is the corner cube, which is useless because it has 3 faces painted. We want 2 faces painted. This is 1, 2, and 3. 3 on this side, right? 6 smaller cubes with exactly 2 faces, one painted with blue, another painted with green, right? Fine. So this is painted with, one face is painted with blue, another with green, and there are how many like that? This is red, this is blue, this is green. Oh no, this is red and blue interaction we are looking at. We have to look for this red and green interaction. Red and green interaction. So there is, if this side you take, if you consider this, let me redraw. So this is red, this is 7, 5, 3, then this is 5 into 3 is green, no? This is green, this is blue, and this is blue, and this is green. So we are looking at blue-green interaction. So this interaction we are looking for 1, 2, this 3, and this 4, right? So if I draw this 1, 2, 1, 2, so because this side is 3, and this is a corner piece. This is useless because this had 3 faces painted. We are interested in only 2 faces painted. One is green and one is blue. So this is only 1 on one side, 2 on this side, 1, 2, then 3 and 4, right? No more than that. Correct? Yes. Yes, green and blue. So 1, 2, 3, 4. 4 cubes are like this, not 6. So answer here is A1 only. Next, 125 identical cubes are arranged in the form of cubical block. So you know that 125 is a 5 cube. So we have cube of side 5 into 5 into 5, and it is being cut into 125 smaller cubes. Fine. Question is, how many cubes are surrounded by other cubes from each side? Basically, we want a cube that is not exposed to the surface. Exactly like previous question, we have to come one inside from each side. So 5 minus 2, 5 minus 2, 5 minus 2. So there is an inside cube, inside a bigger cube of 5, which are offside 3 into 3 into 3. And no cube of that smaller cube is exposed to outside. That is covered by other cubes by on the all sides. That is the thing. So we have 3 into 3 into 3. 27 is the answer. Next, CSE 2019C, all the way back, there was a question. The question is, each face of a cube can be painted in black or white colors. Okay. In how many different ways can the cube be painted? Now, this is more a permutation combinations question than cube question. But let us see, each face of a cube can be painted black or white. And in how many different ways can it be painted? Now, any cube can be represented or opened like this. Fine. We want to have each face can be painted black or white, right? So let us count methodically. We can have all the 6 faces black, right? Right? That is only one way to do that. Then what if 5 black, 1 white? That is one way. And there is absolutely one way to do that, because faces of cube are symmetrical. There is absolutely no difference which face you paint black or which face you paint white. That doesn't matter. So there is one way to do that. Fine. Then we have 2 white and 4 black. Now these 2 white can be opposite to each other or adjacent to each other. So there are 2 ways to do that. There is only one choice there. You just have to take 2 whites. They could be adjacent to each other like this, in whichever way. Here, anywhere. The only thing is, only other way is having them opposite, anywhere opposite. And because cube is symmetric, any opposite is same, that doesn't matter. So we have 2 ways of doing it. Then we have 3 black, 3 white. Now this is where the difference is fine. So we have 3 corner things can be white, 3 corner things can be black. That is one way. Let me have it here only. So we have white, 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 and black, black, black. Fine. Then other ways, white, 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 black, black, black. Right? Is there any other way? You can have 3 of these as corner pieces as white. Fine. So there is no 2 whites are opposite to each other, and one way is white, white, white. So we have 2 whites opposite to each other and 1 white somewhere which is not opposite. Correct? And just let us just choose opposite, and all the 4 of whites are then equal. Wherever you want to put it, you can. Right? And rest of the things are taken by black. So there is not a different case but same case. So that is one case. And if we don't want to put white opposite, let us put 2 whites as adjacent, and third white, for third white we can put it here or we can put it that side. There are only 2 choices, but they are not again different choices because cube is symmetrical. So there are 2 choices like this. And similarly we can have 2 black, 4 white. It is same case as this. Then 1 black, 5 white, 1, and 6 white, 1. How many cases? 6 plus 4, we have 10 cases. We just have to count methodically in this case. I hope, I think this was the last question. No, there is one more question. Let us see. Question: a solid cube is painted yellow, blue, and black such that opposite faces are of same color. Fine. We have a cube. We have a solid cube which is being painted, and opposite have yellow, blue, and black. Let us say yellow, yellow, blue, blue, and this is black, and this is black. Okay. The cube is then cut into 36 cubes of 2 different sizes such that 32 cubes are small and other 4 are big. Fine. None of the faces of the bigger cubes are painted blue. So bigger cubes are not on this or that end. Bigger cubes are in the middle. Okay. How many cubes have only one face painted? That is the question. So only information is that there are total 36 cubes and 32 are small, other 4 are big, and big are not on this or on that face. It is somewhere in the middle in this kind of arrangement. So this is a bit of a trial and error thing. This is not really mathematical, so to say. So let us put a line here, right, where these blue things, where bigger things are not there. So bigger things have to be in the middle, and smaller things can occupy ends as well as in the middle. Fine. Because we want to have cubes, let us assume, and we have 36 number of cubes. So perhaps it is 6 by 6 by 6 cube or a smaller cube. Fine. So if we have, and it cannot be 6 by 6 by 6 because some are bigger, some are smaller. So it is smaller. So it is either 5 by 5 by 5 or 4 by 4 by 4 kind of cube. Let us try with 4 by 4 because 6, 4 seems similar. If we have 4 and this side is 2, this is 1, this is 1, this is 4, then we want 2, then it has to be halfway here cut, so that this is 2, this is 2, and we have this 2. So we have 2 by 2 by cube, 2 by 2 by 2 cube here, 1, 1, 2, 3, and 4. 4 bigger cubes can sit in the middle, and this is 4, this is 1. So 1, 2, 3, and 4 here, and 4 here. So how many are there? 16 are sitting on this face, 16 are sitting in this face. So everything fits. This should be the arrangement. Then, right, this is blue, this is black, this is yellow. This arrangement fits. Again, we were just trying. There is no one way to arrive at this. Only thing we know that blue surface pe bigger cubes cannot be on the blue surface. So it has to be inside in the middle. And because size is 36 cubes, so I have taken not 6 by 6 by 6, but I think 4 was a better choice. And that's how, with little bit of trial and error, we come to the conclusion. And question here is, how many cubes have only one face painted? Let us go back to our figure. Only one face painted, meaning in the middle. So these corner pieces have always 3 faces painted. So they are gone. They are gone. And these bigger cubes have 2 faces painted. 1, 2, 1 and bottom, 1 and bottom, 1 and bottom. Right? So they are out. So these 8 are out. These 4 are out. So 12 are out of 36. What else? What else? So we have here whatever there are on the edge, they are also out, because edge meaning 2 faces being painted. So we want cubes that are not on the edge but on the surface of this. This is 4 by 4 by 4. We want only on the surface. So these 4 are the ones we are looking for. 4 on this side and 4 on this side. That is all. So total is 8. Answer here is C, 8. Answer here is C, 8. This was a difficult question to attempt in examination hall because it required little trial and error, the kind of thing, which is fine. One or two questions can be difficult, no problem. But this is how you could have done it. And yes, I hope it was helpful. This was one of those topics which requires some imagination, and you need to spend some time, which we are able to do better in our classrooms. And there I can spend more time on explaining things in a better way until every one of you understand. And yes, we are starting our CSAT Foundation Batch 2.0 from tomorrow, 8th of January 2024. You are welcome for demo lectures, and I hope to see many of you there. Thank you. We'll continue this series then.